Welcome to Pythagoras Theorem. Just before we start, a reminder that there is a notes jotter available for this video. Just check the description below for a download link and you can work along with me as we go through the video. Okay, so just before we start, it's very important that we know a few definitions about triangles for Pythagoras Theorem, because we're only going to deal with right angled triangles here, and we're often going to be talking about the hypotenuse. Now the important thing is where the hypotenuse is. The hypotenuse will always be on the longest side of the triangle, and the way to find the longest side of a triangle is that it will always be opposite the right angle. So no matter how this shape is orientated, as long as you can find the side which is opposite the right angle, it will be the hypotenuse and it will be the longest side in that shape. So let's have a look at Pythagoras' theorem. It states that the square on the hypotenuse is equal to the sum of the squares on the other two sides. Now that all sounds very complicated, but all I want to do is I want to show you what this means. Here is a right angled triangle. One side is 3 centimeters, one side is 4 centimeters, and one side is 5 centimeters. Now it says the square on the hypotenuse. Well, the hypotenuse is the longest side. And by square, what it means is if we continued this shape and produced a square on that hypotenuse, it will be a 5 by 5 square. And so the area of this square would be 25. Now, if we did the square on the other two sides, well, the square on the 3 centimeter side would be a 3 by 3 square. It would have an area of 9. And if I did the same on the 4 centimeter side, it would be a 4 by 4 square. It would have an area of 16. What it states here is the square on the hypotenuse, 25, is equal to the sum of the squares on the other two sides. Well, 25 equals 9 plus 16. And so the two squares on this side add together to make the square on this side. And it leads to a formula. A squared plus b squared equals c squared. Now, if you're going to use this formula, you have to be very careful. C must always be the hypotenuse. If you're using a squared plus b squared equals c squared, the c must always be the hypotenuse. And you'll see why when we come to some questions later on. Okay, so we're going to begin by trying to find the hypotenuse of some right angled triangles. And so in each case, what I want to begin with is I want to begin with that formula. A squared plus b squared equals c squared, and I'm going to keep writing this just so that it gets absolutely stuck in my head every time I try to attempt a question about Pythagoras' theorem. And in this case, remember, c must always be the hypotenuse, and therefore this one is going to equal x squared. The a and the b, it then doesn't really matter that much, but generally I would say b is the base just because it begins with b, and a is the other side, and so 6 squared plus 8 squared equals x squared. Now in some of these cases these questions will be non-calculator, and that's because the square numbers involved are ones that we should be aware of. 6 squared is 36 and 8 squared is 64. Now that still must equal x squared. What is 36 plus 64? Well, that is 100. And so 100 is x squared. Now how would I find the value of x, the actual length of the side? Well, I would need to square root, and so x is actually the square root of 100. And given that 100 is a square number, we can find the square root quite easily. The square root of 100 is 10, and therefore the hypotenuse of the first triangle is 10 centimeters. In the second question, we have x as our hypotenuse, we have 9 as what we would call A, and 5 is what we would call b. And if we make our little formula, a squared plus b squared equals c squared, well, we just fill in our values. So a is 9, so 9 squared plus 5 squared equals x squared. What is 9 squared? Well, 9 squared is 81, 5 squared is 25, and x squared is still exactly as it was. And 81 plus 25, well, that is 106 is x squared. Now, 106, that is not something which I'm aware of as a square number, and therefore, if I want to find x this time, I'm going to have to go to my calculator. So x would be the square root of 106. Bring up the calculator, square root of 106, and that tells us it's the square root of 106, but if we turn it into a decimal, we get 10.2956. So if we went, in this case, to 2 decimal places, it'd be 10.30. 10.30 centimetres. And finally, in this case, I just want to remind you of what I said about the orientation of the shape. The hypotenuse will always be opposite the right angle, and therefore x is still the hypotenuse. Even though it's not in the same kind of position as we've seen previously, it is still the longest side in this triangle. In terms of a and b, either way around, it doesn't really matter which one we call a or b. And so, in this case, we have a squared plus b squared equals c squared. Replace our values, so 10 squared plus 7 squared equals x squared, and then let's just work out our different values. So 10 squared is 100, 7 squared is 49, and that equals x squared. So if we continue, 100 plus 49 is 149, and that's what x squared is. So if I want to get x all on its own, I'm going to have to take the square root again. So x is the square root of 149, and again, grab the calculator. Square root of 149 is 12.21 centimetres. So in the next set of examples, we're trying to find one of the shorter sides. So we know it's a shorter side because the hypotenuse must always be the longest side. And in this first one, our hypotenuse is the 13. In our second, our hypotenuse is the 14. And in the last one, our hypotenuse is the 9.9, always opposite the right angle. Therefore, the x is actually one of our shorter sides. And so when we label it here, we would call this one A, and this one B, and this one C. And so in our formula, we have a squared plus b squared equals c squared. But this time, that's going to mean I have 5 squared plus x squared equals 13 squared. And so I'm going to have to think a little bit more carefully about how I'm actually going to solve this one. I'm still just going to work out what 5 squared and 13 squared are. So 5 squared is 25, and 13 squared is 169. How would I get x squared on its own? Well, the first thing I would have to actually do is to get rid of this 25. So I'm going to subtract 25 on both sides. And so x squared equals 144. How would I then get x? Well, x would have to be the square root of 144. And the square root of 144, if you know your square numbers, well, that is 12. Now you'll notice here that I had to do a subtraction. I didn't do that in the previous questions, but that was because I was trying to find the hypotenuse. Anytime you're finding a shorter side, you will need to subtract at some point. So let's see how that happens in the next one. So again, our hypotenuse is opposite the right angle, and therefore 14 is what we would call C. We would have B for our base and A for the other side. And so if I write my formula, it's a squared plus b squared equals c squared. A is x, so it's x squared plus b squared, which was 8.2 squared, and c squared, which is 14 squared. How am I going to get the answers this time? Well, again, here I'm actually going to need my calculator in order to find the different square values. So 8.2 squared is 67.24, and so that's telling me x squared plus 62.74 equals, and 14 squared, I know that is 196. How would I get x squared all on its own? Well, I would need to subtract the 62.74, and so I will do that to both sides. 62.74 subtracted from both, and so x squared would be, 67.24, I've used the wrong values here, 67.24, and so 196, take away my answer, would be 128.76. 128.76. But how do I get x squared x all on its own? I would need to square root this, and so square root the entire answer. And again, I can just do that by typing square root ants, and it comes to 11.35 centimeters if we went to 2 decimal places. And so our final question, again, the orientation of the shape is quite strange. We've flipped it, but it really doesn't matter. Again, it's all just about the labelling of the shape. So the side which is opposite the right angle must be C, and then A and B, it actually doesn't really matter which way we put them. And so, once again, A squared plus B squared equals C squared. A is x, so x squared plus 7 squared equals 9.9 squared. That tells us that x squared plus 49 equals 9.9 squared. Again, I'm going to need my calculator for that one. 9.9 squared is 98.01. And then, if I need to get x squared all on its own, well, I'm going to have to subtract. I will need to subtract this 49. So x squared equals 98.01, take away 49. And that is 49.01. And then if I want to get x all on its own, let's do a square root of that. So x equals the square root of 49.01. And if I type that in, square root of my answer, well, that is 7.000714. So if we were going to one or 2 decimal places, it would be 7.00 centimeters. And finally, we come to some functional questions. Now, these questions at first appearance do not look like a question on Pythagoras because there aren't any right-angled triangles drawn. But what we need to do is we need to draw a few sketches just to see what's going on in the question and see if we can find the right-angled triangles. So a 5-meter long ladder is set against a wall 2 meters from the base. How far up the wall does the ladder reach? Well, the first thing we need to think here is the ground is going to be level. So there is the ground, and then when we build a wall, it's going to be at a right angle to the wall. That is how we make sure that the wall stays standing. And so there's going to be a right angle. And then we get a ladder. The ladder leans against the wall. And then all we need to think about is the information we've actually been given. So we were told that the ladder was 5 meters long, meaning that this is 5 meters. We were also told it was set 2 meters from the base. Now that means we're talking about this distance along the bottom. And so it was 2 meters from the base of the wall. The question is, how far up the wall does it reach? And therefore there is our value x. Now in this situation, we now have a right-angled triangle where we know 2 sides and we want to find a third. That is Pythagoras' theorem. And so we just need to identify A, B and C. Well, here is our right angle, and therefore the ladder is our C. It is our hypotenuse. The base is going to be the 2, and so x is going to be our A. A squared plus B squared equals C squared. Fill in the values. Well, A is x, B is 2, and C is 5. And so let's just work out each value in there. Well, 2 squared is 4, 5 squared is 25. How am I going to get x squared on its own? Well, I will need to subtract. So x squared equals 25, take away 4, which is 21. And therefore, if I need to get x all on its own, which is what I want to know, how far up the wall will it reach? Well, I will need to do the square root of 21. And the square root of 21 is 4.58 to 2 decimal places. So 4.58 meters. Next, a boat sails 30 miles north, then turns east and travels a further 25 miles. What is the direct distance from the starting point to the end point? Well, in this case, we need to start off with a starting point. So we start here. And if we travel north, well, that will mean we go straight up. And we've travelled 30 miles. So let's just mark that we've gone 30 miles north. Now, if we turn east, if we just think about our compass quickly, we have north, east, south, west. And therefore, we have turned to the right. We've gone to pointing towards east. And we've travelled, again, 25 miles from there. Now, the key here is that with a compass, between north and east is 90 degrees. Between east and south is 90 degrees. South and west, 90 degrees. West and north, 90 degrees. And therefore, the turn that I have made is a 90-degree turn. Now, the question was, what is the direct distance from the starting point to the end point? And so what it actually is asking for is, what is the distance from this starting point to this end point? And so this is x. This is what we want to find out. Now, again, in this question, we need to know which bit is the a hypotenuse. And so here is our right angle. The side opposite it is our hypotenuse, and therefore x is c. A and b, again, it doesn't really matter which way around we put them, because all we're going to say is that a squared plus b squared equals c squared. And a, we've said, is 30, so 30 squared plus 25 squared equals c squared. And if we grab our calculator, 30 squared, and I'm just going to add 25 squared, I can do it in one go. That is 1,525. 1,525 is c squared. And therefore, if I want to get x all on its own, really I should have changed these into x's at this point. If I want to get x all on its own, well, that's going to be the square root of 1,525. And if I grab my calculator again, root ants equals 5 root 61, but as a decimal, 39.05. 39.05 miles. And so we end with our exam question, and it came from the Edexcel paper in June 2017. It was on Foundation and Higher paper 1. Now, two things to unpack from that. It was Foundation and Higher, so this is a grade 4 to 5 topic, and it's paper 1, meaning it's a non-calculator question, so we're going to have to deal with our square numbers all out by ourselves here. And so, this rectangular frame is made from 5 straight pieces of metal. The weight of the metal is 1.5 kilograms per metre. Work out the total weight of the metal in the frame. Now, if we have a look at this, we've got a rectangle, but it's been split in half. Now, as you split a rectangle in half, you create 2 right-angled triangles. And so, if we are going to find the weight of this entire shape, we are going to need to know the length of this side, which I've just marked in red. And that makes a right-angled triangle where we have 2 sides which we know and 1 that we need to know. And that side is opposite the right angle. It is our hypotenuse. So that would be C. We'd have B and we'd have A. And so to get C, we need A squared plus B squared equals C squared. A is 5, B is 12, and C Well, we don't know. It's just C. And so 5 squared. Well, 5 squared, 5 times 5, 25. And 12 squared, 12 times 12, 144. It equals C squared. And 25 plus 144, well, that is 169. And what we need to recognise here is that C is the square root of 169, and that 169 is a square number. 169 is 13 squared. Therefore, this length is 13 metres. Now, the question is asking about the weight of the whole frame, and therefore we need to think, what is the frame made of? Well, the frame includes another side of 5 metres and another side of 12 metres, and so in total we have 12 plus 12 plus 5 plus 5 plus 13, and so if we add all of those together we are 24, 29, 34, 37, 47 metres. And then the last little stage of this, it is 1.5 kilograms per metre, and so we need to multiply 47 by 1.5. So 47 times 1.5. Well, a couple of ways that you can do this. A method I quite like is using Napier's bones. So that is 47 times 1.5. 4 times 1 is 4. 7 times 1 is 7. 4 times 5 is 20. 7 times 5 is 35. And so 5 is in the first diagonal. 7 plus 3 is 10. So carry that over. 4 plus 2 plus 1 is 7. And then we need to place our decimal point in here. And so we take our decimal point and we follow the arrow. It takes us to 70.5 kilograms.